Welcome back, guys. So today I'm going to start with the queue. So if you try to remember, in linked list I was talking about the few methods which we mainly use for queue implementations, right? So we'll try to understand into the details what is queue. So basically queue is the interface, right? Queue is not a class. Queue, it is an interface, and this queue is implemented by multiple classes. We will see that the classes which we use to implement the queue interface. This is the hierarchy of your queue interface. If you go here, the hierarchy is queue is the interface which will extend collection, and collection will extend iterable, right? So that's how the hierarchy has been defined. So if you look at here the nodes, queue is used to insert element at the end of the queue and removes from the beginning of the queue. So basically insertions will happen at the end and removal will happen from the beginning. So if I have to show through the diagram, you can understand. Let's say assume that this is queue. Okay, so you are inserting from here, you are inserting like 1 2 3 4. So when you insert, it will get inserted at the end. So this is the end, but when you remove, it will get removed from here. So removal will happen from here and the insertions will happen at the end of the queue. So that is the reason we always call queue as a FIFO concept. So first in, okay, whatever will be the first in will be first out. So if you look at this, one was inserted first. So when you remove, one will get removed first. Second was inserted after first. So second will get removed after first. That is the reason we call it as FIFO. First in, first out. This was the first in. This is going to be out first, right? Java queue supports all method of collections interface, including insertion, deletion, etc. So whatever method we have in the collection interface, it supports all the method. So as of now, whatever method you have seen, which I have shown you in the array list and linked list, actually it will support all the method. Okay, so the method which we have already learned in the array list or linked list, we will not repeat that. Here our primary aim is to learn the method which is specific to the queue interface. Okay, we will see that what are the method we have in the queue interface, and that's what we will try to understand, and that's what it is important from interview point of view, right? So please remember that queue is the interface, okay, and insertions happen at the end, removal happens from the beginning. That is the reason we call it as FIFO, first in, first out. So this was the first in, like when you inserted into a data structure, either array list or linked list, this is the first. So first was added, first is getting removed, right? But when you add, it is getting added at the end. So if, let's say, if you are implementing queue by using array list, if you look at like this, right? So this is the one, this is the index, right? 1 2 3 4. So when you add the data, basically it will get added this way, right? But when you remove, this will get removed. Then again when you remove, this will get removed. That's how removal happens. So removal happens from the beginning, right? The classes which implements queue, mostly we use these things. Mostly we use linked list, array blocking queue, and priority queue. So these are the classes we mostly use to implement queue interface, because these are the classes, right? So since queue is the interface, we need to have the corresponding class which will implement your interface, right? Now we will try to understand the methods of the queue, which is very, very important. So if you look at the method, the first method, the add method, okay, the add method in the queue, return type is the boolean, and it will add the object. It will add the object to the queue. So what is E? E is nothing but the type of object which you are going to add. So let's say if you are going to add a string, right? So E will be a string. If you are going to add integer, so E will be integer, right? So E is nothing but the type of object which you are going to add into the queue. So you can read this. So what happens? This add method insert the specific element in the queue, right? If it is possible to do so immediately without violating capacity restriction. What does mean by that? We will understand through the code. Return true upon success and throwing an illegal state exceptions if there is no space. So what happens? Let's say you have a queue and your queue is the interface, and your implemented class is array blocking queue. So linked list blocking queue or array list blocking queue, that is the implementations which we will see that in the code here. Just try to understand. So in that we can define the capacity of the queue. So we can define the capacity is equal to, let's say, 2. So you cannot add more than 2. So through add method, if you try to add more than 2, more than the capacity, it will throw the exceptions, illegal state exceptions. In case of add method, this add method will throw the exceptions, right? Whereas the offer method, there is a method again, this guy offer, this also insert the data into the queue, but this will not throw the exceptions if your queue is full. So the difference between add method and offer method is add method will throw the exceptions when your queue is full, whereas your offer method, this method will not throw the exceptions when your queue is full. That is the difference. Both method will add the data to the queue. Now what is element? See, what retrieve but does not remove the head of the queue. So when you perform element, when you call the element method on the reference of queue, the return type is the E. The E is nothing but the data which you have inserted into the queue. So when you call this method element, basically it will retrieve, but it will not remove the data from the queue, right? And basically it will give you the head means linked list implementation. So it will give you the head, but it will not remove the pick. So the pick, what it will do, retrieve but does not remove again the head of the queue, or return null if the queue is empty, right? So the difference between pick and element is element will retrieve but does not remove the head of the queue. Here pick retrieve but does not remove the head of the queue, or return null if queue is empty. So here you will get null also. When you call pick method, you will get a null. Okay. We will see that through code you will understand better, like how element and pick will work. Like similarly you can see that how add and offer method will work. Everything you can understand through the code. Okay, here just try to remember these methods. People will ask you in the interview. Okay, so you have to tell that, like they will ask you what is element, you have to say that element, when you call the element method, it will give the head of the queue, but it will not remove from the queue. The pick method, this also will retrieve but will not remove the head of the queue, or it will give you null when there is no data in the queue. Now pull method. So there is another method called pull method. See, these all element method, pick method and pull method, these are all similar. Okay, only the way it works is different. The pull is retrieve and remove. See here, when you call pull method, this guy will retrieve, it will give you the data, as well as it will remove the data from the queue, or return null if the queue is empty. So this guy actually will remove the data from the queue, right? Then there is something called remove also. So retrieve and remove the head of the queue. So this guy will give the retrieve and remove the head of the queue. See, all, if you look at this method definition wise, it looks very same, but we have to see that implementation wise how this will work, right? So all method we will understand only when it will go through the implementations of the method. Okay, now these are the methods you have the queue. So please remember methods: add method, element method, offer method, pick method, pull method and remove method. These are the methods you have in the queue interface. Now what are the classes? So before jumping to the classes, the queue will also inherit the methods from the collection. From the collections it will inherit all the methods, like these are the all methods: add all, clear, contains all, equals, hash code, is empty, iterator, remove all, retain all, size, to array. So these all methods we have seen that when I was talking about the array list or linked list, right? All method we have seen that, like add all, clear, contains all, equals, hash code, everything we have seen that. So this method I will just give you the brief idea of, I will not go into the details because this I have already covered. Where I will focus more is on this queue methods. Okay, so let's start with queue implementations. Guys, please remember this: queue implements collection, queue extends collection, and collection extends iterable. So please remember this is very important. And queue is FIFO, first in first out. Please remember this 2 points. Now we will start with the implementations of queue. So let me launch my Eclipse. Okay, so here I have a class example one. If you look at here, and if you look at This is the 4 important implementation just we need to know. Actually, if you ask me to be very honest, we should know only these implementations which is widely used. But again, from interview point of view, you should know these implementations also. So when I say implementations, which means the classes which will implement the queue interface. So again, queue, if you go inside the queue, press Control and click on queue. So queue is the interface. This guy extends collection, right? And in the queue interface, when you press Control O, these are the method: add method, offer method, remove method, pull method, element method, and pick method, right? So here also you can read that they have given clear, when you click on add, they have given all the notes here, like what add will do. So you can read here also, if you have interest and time, you can read that, right? Now this guy extends collection. Collection is the interface. When you click on collection, when you click on collections, this guy is the interface, and collections extends iterable, right? So again, press Command O. See, collections also has this many method. This collection interface has this method: size, empty, contains, iterator, to array, remove, retain. So these are all present in the collection interface basically. Okay, so these all comes from the collections interface. Now when you press Control and click on iterable, and when you go inside the iterable and when you press Command O, the iterable has only 3 methods: iterator, for each, and split iterator. Okay, so split iterator. So only you have 3 methods. So basically, see, you know that like when one interface extends other interface, this interface will acquire, actually it has all the method of iterable also, right? This interface. Now since what happens is your queue extends collections, so this guy will have all the method of the collection as well as iterable. Okay, so queue will have all the methods of collections and iterable. So whatever class will implement queue interface, that class need to have all the implementations of the collections methods, of the queue methods, and of the iterable methods. Okay, whatever class will implement, that's what I was trying to say that. So if you go back now in example 1, so how do you create queue basically? You can, let me do one thing, let me just freshly let me remove everything, import, because that's where people will always get confused. So just write queue. Okay, you can see that queue, where it is present, Java util package. This is a part of Java util package. Click on that. What is E? The type of object. So E I am going to store as, let's say, a string. I am going to store a string, and as I told earlier, just press Control space bar. When you press Control space bar, it will give you the options to create the reference. So I will select queue, and then I will write queue can be implemented by array list also. Okay, but usually people, they don't use it. New array list. Okay, new array list. All right. Okay. Sorry. Okay, so the why you are getting that here compile time error, because you cannot keep 2 reference with the same name. So make it here Q4, right? Okay, still you are seeing that some problem. Why you are seeing that the problem? The reason is, when you try to implement queue with the array list, okay, you cannot do that, because there are few methods in the array list which is not implemented, few methods in the queue which is not implemented by the array list. So you have to here see, you have to cast the array list into queue. So do not do that. That is the reason we don't do that by using array list. We don't do that. So the better is go for linked list always, because linked list will have all the implementations of queue has, right? So whatever queue has, it will have all the implementations. Now what is the problem? We'll try to figure out now why it is complaining. It is complaining because we have not imported linked list. right? We are making the object, we have not imported, so click on, it should be always from Java util package, import that. So now this should not complain, and the problem is now again it is complaining. The reason is here I have a string, so here also it should be a string. Okay, type should match, object type should match. Now this also object will work fine. Now there is another implementations of queue is the interface. The another implementations is add a blocking queue. Add a blocking queue is the another implementations. Again press mouse over here, import this. It will be available in the Java util concurrent package, so click on that. Here you will be seeing one thing. I am using capacity is equal to 1. I will tell you why I am using that. Then go to array dequeue, import that, present in the Java util package, and then linked blocking queue, import that. Okay, so look at here, you know that this linked list will have multiple constructor. Okay, so you can create the object of all the constructor, guys. There is no hard and fast rule. You can use anyone. Either you can use linked list of collection. So it's up to you whether you want to use default one or you want to use a linked list which has collections of object, which I have shown you in the linked list chapter, right? So here I will not cover. So you can use anyone. Similarly, what happens is when you want to use array blocking queue, okay, when you want to implement through array blocking queue, I wanted to show you the constructor so that see this array blocking queue. Basically it has if you look at 3 constructor, one is capacity, one is capacity and boolean fair, and then one is capacity, boolean fair, and then collection, right? So here I think one would be the enough. You should know this array blocking queue with capacity, okay, because we have n number of classes in the collections framework. I don't think so you need to remember everything. You should know we should know which is people they use in the industry. Okay, so here I am using that the capacity, so I have used this guy. If you look at, I did the same thing. I use array blocking queue. Why I have used array blocking queue? There is a reason for that. I would have completed everything by using linked list. Still I went to array blocking queue. There is a reason for that. Then there is something called array dequeue. So array dequeue, if you look at here in the array dequeue also will have this is also a class. This also has actually 3 constructor. One is with no argument, one array dequeue with collections of object as an argument, one array dequeue which will take num elements, like which will take, you can specify the type of the data type, the object type you can specify. So there are 3 constructors. It's up to you which one you want to use. My suggestion is you can go for the which has the size, capacity, that's it. Now there is something called linked blocking queue. So the linked blocking queue, here also linked blocking queue have 3 constructor. One is default, one which will take collections of object, and one which will take capacity, right? So why I have used capacity one? There is a reason for that which I will tell you. Now let me quickly show you why these are the things I have used. See, this is the queue. Assume that, okay, I don't need this. This is enough to explain the queue. Let me remove the unused import. Okay, so look at this queue. I am using the reference of queue, so I can use the method of queue. Now queue dot add. Okay, since it is an integer, I can add multiple integers. I can add it here, right? And if I print, there will not be any issue. Okay, when I print this, run as Java applications, there is no issue. Okay, 10 10 10 is getting printed. In fact, you can use 100 also. It's up to you, right? Now what is blocking queue? And again, instead of add method, if you use offer also, so if you use 300, if you use 400, if you use 600, and let's say this one you write in the print statement, because this will add and it will return also, so that you can correlate how this works, right? What is the meaning of return type, because it will add and it will return the boolean also. Okay, so if I have to run this, see, look at here, true means got added to the queue, and this is your final queue. So data is getting added, right? and the implementation is linked list. Then what is array blocking queue? And here you will understand the difference between, so let me do one thing, here use add and offer. Okay, you know that both are used to add it, so use add and offer, so mixture of both, right? And here also you use offer, so mixture of both. One is add method, one is offer method, both does the same job. So if you look at here, see, both are true. Now same data you copy from here, come to blocking queue. Okay, now you will see the difference. When you have a blocking queue, you should always use offer, you should not use add. The reason is, when you have a blocking queue and you have a capacity defined, like this blocking queue will not take more than one size, it will not take more than one size, you have a requirement. So here you should not use add method. If I run this, see, you can see that illegal state exceptions, that's what I was mentioning, right? So when you have a blocking queue and when you are trying to add more than the size of the queue, you will get exceptions, illegal state exceptions. You can see that illegal state exceptions, right? So when you, from where it is coming, line number 24, this is coming from line number 24. When you click on this line number 24, it is coming from here, because size is only 1, so you can add only 1, you cannot add more. But what if in the same blocking queue, let's say this is blocking queue 5, okay, what if in the blocking queue you have only offer, there is no add method? Will this still break? It will not break. When you have only offer, what it will do, even though the capacity of queue is full, okay, it will not add and it will not throw the exceptions. It will not throw the exceptions. That is the benefit. So for just to show that, what I have to do, I have to comment this, otherwise it will throw the exceptions here. Now if I run that, you can see that this Q5 will get printed. You can see that 10 is getting printed. Okay, but before printing, what happens here is plus okay, same thing I will copy here. You can see the difference, basically what happens. Now you can see that the different outputs. So offer, when it is not added, it will give you false. When it is added, it will give you true. So this got added, offer, because it was size only 1, right? So this guy size only 1. So first one got added. Second one is false because 600 did not get added, and then print 10, right? So this is the benefit. Here you should use offer method when you have implementations of array blocking queue. Do not use add method. When you will use add method, it will throw the exceptions, like illegal state exceptions. That's what it happened here. It was throwing the exceptions, right? Now array DQ. Array DQ, you don't have any issue. Same, I can copy paste here, select this, control, forward, backslash, it will get uncommented. Now here the benefit with array DQ is you can add both, no problem. Okay, so and also copy this so that we will understand better. Plus dot add 10. Now let's see that here what output we will get. See here, true and false. Okay. So when you see here offer, it was false. You can see that you have added. Okay, sorry, I did one mistake, guys. It's my fault. I was thinking why it came false. Here I used the reference 5. Okay, I should have used 2 because here my reference of array DQ is 2. That's what I was wondering, like why output is not coming as expected. So if you see here now, see everything is true. So in array DQ what happens, though you have a size defined, whether you call add method or offer method, all data will get inserted and your size will grow. Okay, because this is not blocking queue, this is not array blocking queue, this is array blocking queue, and this is array DQ, right? So in array DQ, though you have a size defined, still it will grow internally, and you can see that I am calling 2 times add method and then offer method. So both the data is getting inserted. So again, if you have a requirement where though you have a size but you want to insert everything, go for array DQ implementations. Now the last one, last implementations, here also it will be similar to array blocking queue. Okay, it will not be different. So let me remove this and let me copy this, just change to, see here we should get exception because we are using that blocking queue and we have a capacity 1 and we are going to add data two times. So 2 times we are going to add that. So here what will happen, add that, when you try to add 2 times a data in the blocking queue, okay, in the blocking queue it will throw no such element exceptions, queue is full. So when you run this, see it came here, queue is full, illegal state exceptions, sorry, no such note, it will get illegal state exceptions, queue is full. So if you look at the first 10 got added, right? Let me put this so that it will not be any confusion for you. Now look at this, got printed, then first data got added, 10 got added because there was a size of 1, this linked blocking queue, then it came is full, you cannot add that, again you cannot add that. But if you have, after one add, if you have only offer, you will not see this problem, right? So let's say you have this and you have only offer. So let me comment this. Okay, let me comment this and I will use as Q4. So this is like same like array blocking queue. Okay, now what I will do is I will not add, I will use offer, right? Now if I run that, I will not have any issue and my final queue will get printed. Just to differentiate in the output, change the data. So you can see that now there is no exceptions. Okay, there is no exceptions. So first 10 got added, then 600 came false. So why only one is coming false? Because we are printing only this 600. So if you want to print everything, you can print this. Definitely first time you wanted to learn that, so please use this technique. Okay, always you should use that. This is 300 and this is 400. So you can see that what data is getting inserted, what data is not getting inserted. Now if I run that, I will get a lot of false. You can see that first true, then 3 false. So this 10 is true, this guy is true, then everything, this or fold data will go as a false because you have a size of only 1 and it's a blocking queue, it's a linked blocking queue. Okay, So see, all for false, only one true, final your q is 10, only size 10. So that's how it works guys, right? And I'm hoping that I'm clear now, okay, and you understood all the concept. So how this works. So only two things you need to understand here. One is you prefer to use linked list implementations. If you have to use blocking queue, please go for array blocking queue where you can define the size. But when you are using array blocking DQ, please do not use add method, use offer method. In the linked list implementations, you can use anything offer add. When you have array blocking DQ, please use anything, it will work fine, either offer or add. No, nothing will happen, no exceptions will come. In array blocking queue, yes, exceptions will come. Here I have used only offer. So in array blocking queue, please use only offer, do not use add, it will give you the exceptions. Okay. In array DQ, use both, use add and use offer, you will not get any exceptions. I have shown you. And when you have linked blocking queue, so wherever blocking queue will come and whenever you are using a size, okay, use only offer method, because offer method will not throw the exceptions. Only the add method will throw the exceptions, right, which we have seen that. So with this I will close this video. In next video I will talk about some more important concepts of the queue. Thank you guys.